my name is Madeline Steinecker, and in this project I looked at the amount of fluoride that is absorbed in the mouth from drinking water. This project is actually a continuation project from last year, when I looked at water fluoridation in general. And this is because last year I took the class AP Biology, and in this class I learned that the two most dangerous elements on the periodic table are fluoride, because of its increased and highest level of electronegativity, and francium, which has the highest level of activity on the periodic table. And so in this class I learned the dangerous nature of both of those elements. And so when choosing a science fair project last year, I remembered learning those two things in AP Biology. And because I'm a runner, I drink tons and tons of water. And I know that in Louisville, we use water fluoridation. And so I decided to go in that avenue to look at the too much fluoride in water can be dangerous, because I know the nature of this element. And this year, I continued that research, and I found that there are actually 3 different compounds that are typically added to water fluoridation. And those are sodium fluoride, fluorosilicic acid, and sodium fluorosilicate. And in Louisville, based upon this state summary of data, Kentucky uses this fluorosilicic acid. So I decided to do some research on this fluorosilicic acid. And I found from this Environmental Science and Policy academic journal that this fluorosilicic acid has been shown to leach lead from water delivery plumbing. The Environmental Protection Agency health-based drinking water standards for arsenic and lead are 0. And part of the reason why this lead could possibly be leached is because this treatment of water is industrial. It's not pharmaceutical grade. And so that means that they're not regulating this water as closely as they should be. And so we can't assume that the water is free from the arsenic and lead unless it is verified no based upon this article. And this is very concerning for water companies, because the EPA standards are zero tolerance for lead and arsenic into the water. Moreover, the fluorosilicic acid is not being regulated in the water. And the reasoning that these water companies are still continuing to use this fluorosilicic acid despite these risks is because they believe that the benefits outweigh the risks. The benefits being that it's a cheaper mechanism to fluoridate the water, and also that water fluoridation is proven to help with dental decay. So you're probably wondering why I have a halogen lamp and an LED light sitting next to me. And I'm going to introduce that a little bit more later. But I want you to begin thinking about the fact that fluoride is a halogen. And we can learn a lot from the technology difference between the halogen light and the LED light, and how there's been a transition of using both of these things to light our world. And so we're going to look closely into that later on, but I just wanted you to start thinking about this difference in technology for the older halogen light and then the newer, the LED light. This brings me to my project this year, which is analyzing the amount of fluoride absorbed into the mouth. Through my research, I learned that the optimal level of fluoride in drinking water is between 0.6 parts per million to 1.2 parts per million. This is interesting because only 0.01 parts per million to 0.06 parts per million is being absorbed into the saliva, which is the mechanism that's protecting the teeth. And so I wondered, where is the rest of the fluoride going that is being put into your body from this water fluoridation? And so that brought me to this research. In my research, I tested whether the water is being absorbed in the mouth or not. And I did this by collecting a water sample from a Prospect residence and from North Oldham Middle School. I tested both of these samples for their initial fluoride concentration. I then had an individual younger than 18, an individual between 18 and 50, and an individual 50 or older take the sample and swirl it in their mouth for 1 second, spit it out, and then 3 seconds, spit it out, so on and so forth, 5 seconds and 10 seconds. And And then I took each of these samples and I tested them for their fluoride concentration. This procedure is demonstrated here in these photos. I then used a fluoride probe and test set 2 to test the fluoride concentration of each sample. The results are demonstrated on these graphs. As you can see, the initial levels of the fluoride concentration in the Prospect residence and Oldham Middle School did decrease in all of my samples. However, this is very, very minimal, approximately 0.1 parts per million across all samples. This means that approximately 12.5% of fluoride was absorbed into the mouth. This is, again, a very minimal quantity of fluoride. So, where then is the rest of this fluoride going?
You were here, which is kind of neat.
He likes to document.
Yes, documentation is always fun. Thank you for showing us into this room, and we'll go on about our procedure.
What if you want? Alright, so which one do you want to do first? This one? Ionic strength buffer, so that way it's easier to read it. And then it's got just one side. Try it. Stick it up. Already turned on.
So where's the sample?
Oh,
right there.
Yeah.
This is, this is
Do we move it out of the way?
Good.
Our water is around, it can be anywhere from around there to like 0.79, 0.78. It varies actually daily, like, so. And it might mix out in the system. Like today it was 0.79.
You're putting 10 in there, right?
Yep.
Is that a full 10 there?
Oh, it's right there, sorry.
What? Yes, it's full 10.
Okay.
And then you have to add the test tab. You have to do the test tab first.
Oh.
Yeah. Start timer for 3 minutes.
I told him that I was interested in pursuing this project because last year I just did fluoride in general and researched that. And then he put me into contact with a couple people from the water company, and then I think you're kind of the last person that they said to use.
I got the electrocution. I love that. I love IDing fish.
That is
It's
cool.
so fun.
Electrofish.
Except for sometimes you reach in and grab cropland. What are you gonna do?
Yeah, that is
Gosh,
cool.
I don't know.
Get my feel for poison control considerations.
Do you have siblings?
Three.
The most exciting thing we did was make tie-dyed shirts.
Really?
Yeah. Nothing else.
Just getting the anomaly. Where did
Okay.
that
The primary reason why this experiment is so significant is the fact that it has never been done before. According to Eurpoa Public Health, there is no proven absorption of fluoride into the mouth. And this experiment has probably never been done before because of the fact that we put fluoride into the water so it can go into your body to get to the saliva. That's the main reason why it's being put in the body. This experiment was just looking at how much is going into the mouth. Is there a substantial amount of the fluoride that's going into your body that is being put into the mouth, that's getting direct contact with the teeth? And so, based upon this experiment, we presumed that after 10 seconds, there would probably be more absorption into the mouth because it's been sitting in the mouth longer, so maybe it was absorbed into the teeth. But as you can see, based upon these graphs, that hypothesis was rejected because it was still very, very minimal. And the graph trend continued over the 3 seconds, 5 seconds, and 10 seconds. Fluoride is not added to drinking water to help your bones. It is added to drinking water to specifically target your teeth to help with demineralization. As you can see from this graph here, or from this model here, when this is a demonstration of demineralization of the fluoride with the water fluoridation present. And so demineralization occurs when you're drinking sugary foods. And so basically, this hydroxyapatite is coming out, and you have, this is your biofilm in your teeth. And so this fluoride is attaching to the, once again, fluoride is being added to the water to help prevent tooth decay. However, in my research I found that 50% of fluoride is, 50% of the fluoride consumed binds to your bone. Could that potentially be a problem? Dense bones doesn't always mean strong bones. In an article published by Carefree Dental, 7 things you can do to prevent tooth decay, not one of the 7 things that they mention has to do with drinking fluoridated water. I'd like to draw your attention to this model. This model shows what's happening in your mouth when you're consuming foods high in sugar. Essentially, scientists believed when putting fluoride into the water that the fluoride in the saliva brought by drinking fluoridated water is going to help remineralize the teeth. However, through my research I discovered that there is a very, very small quantity of fluoride in your saliva. And if you're drinking an abundance of sugary foods, which promotes cavity formation, that very minuscule amount of fluoride in the mouth or in the saliva is hardly going to do anything to help those teeth. Additionally, you can see in this model that the fluoroapatite is happening in this location. What if the cavity is over here? One of the main issues with this process is that you can't control where this fluoroapatite is happening, this remineralization is happening. And this ties into this halogen bulb illustration. So iodine and bromine are halogen gases that are used for these halogen lamps. And essentially these gases do not target a certain spot on the wire to provide the tungsten. And so the tungsten could be building up on one side of the wire, whereas the other side there's hardly any at all. And so that's not helping strengthen the wire any. That's just build up over here and then getting really, really tiny over here. You can't control where it's going. And that's very similar to what's happening in this demonstration, or in this illustration. That this fluoroapatite is occurring here, whereas the cavity could be here or here or here, but there's no way that you can specifically make the fluoroapatite happen at a certain point on the tooth using this water fluoridation. However, dentists can target this area of concern by using fluoride treatment, where they can target where the fluoride is going on the mouth. This is why dental care, an increase in dental care, rather than including water fluoridation, is probably the best way to go for treating dental decay. To support my hypothesis that adults are not benefiting from water fluoridation, I brought along an academic journal from PubMed Health. And in this journal, under their key results, they state that they did not find any benefits of fluoridated water for adults. Additionally, you can see in this graph from Newsweek that there are countries that have water fluoridation and countries that don't have water fluoridation. However, the same decreasing trend is noted in all of these countries for their mean number of decayed, missing, or filled teeth. And if these countries don't have water fluoridation, but their rates are still decreasing, then that implies that the water fluoridation is not helping. In conclusion, I have proven that fluoride is absorbed into the mouth. Additionally, I've found evidence that supports my hypothesis that there could be a limiting reactant. This is because there is such a drastic rate of absorption in 1 second across all of my tests. However, at 3 seconds, 5 seconds, and 10 seconds, we notice a stabling or a decrease in the rate of absorption over time. So this could imply that there is that limiting reactant that's preventing this reaction from an increased rate of absorption. Next time, I would like to look at the amount of fluoride that is excreted from the body. In this study from Newsweek, I found that as of 2004, 58% of African Americans had fluorosis, compared to 36% of whites. Fluorosis is a medical condition of absorbing too much fluoride, which last year in my project I learned that too much fluoride in water can be dangerous. So I want to look at the excretion levels of these individuals to see if there is a difference in the amount that they're excreting. With an aging population, we need to be concerned about Medicare costs and taxpayer money. This goes back to the halogen lamp example. This method is an older method. Just like dental care, we used to be putting gold or silver crowns on people's teeth and drilling out cavities and such. But now we have new methods, dental sealants, that are proven to be more effective. That's progression. That's progression from this to this. 2,000 hours of light to 15,000 hours of light, LED light. We are not making a lot of progression with this dental care. And so that is why I need your support for this project to promote further research on whether or not fluoridation of water is the most effective way to treat our population. My project is best in state for 3 reasons. The first one is that no experiment has ever been done to test the level of fluoride absorption in the mouth. Secondly, no reason has ever been given as to why fluoride added to water has no benefit for adults. Finally, fluoridation of water is a billion-dollar investment, and we need to make sure that we're spending tax dollars wisely.